Pop quiz. Which compound has the higher percent of oxygen by mass? Carbon monoxide, carbon dioxide, the same, or not enough information? Lock in your answer. We'll reveal it in a moment. In this video, you will learn what percent composition by mass means, how to calculate it quickly from a formula, then apply it to hydrates and to building an empirical formula from percent data. First, the big idea. Percent composition tells us what fraction of a compound's mass comes from each element. Take the mass contributed by that element in 1 mole, which is equal to its molar mass multiplied by the number of its atoms in the molecule. Divide by the molar mass of the compound, and then multiply by 100%. Let's work on one example. For carbon dioxide, the molar mass is about 44.01 grams per mole. Carbon contributes about 12.01 grams per mole, which is roughly 27.3%. Oxygen contributes about 32 grams per mole, which is roughly 72.7%. Time to reveal the pop quiz. Carbon dioxide wins. It has a greater oxygen share by mass than carbon monoxide. The reason is simple. Carbon dioxide contains 2 oxygens, so oxygen accounts for about 72% of its mass, whereas in carbon monoxide, it makes up only about 57%. Here are 2 quick fixes. First, percent composition is about mass, not about the number of atoms. Second, small rounding differences can cause the percent by mass values to add up to just under or just over 100%. That's completely normal. So far, you can state the definition, apply the percent by mass formula, and compute carbon and oxygen percentages in carbon dioxide. Want to check your progress? Tap the link for a quick practice test and a concise study guide tailored to this lesson. Quiz yourself, skim the highlights, and jump back in. Let's apply the method to a hydrate. In magnesium sulfate heptahydrate, the 7 water molecules are part of the crystal structure. Those waters account for about 51% of the total mass. This is why heating a hydrate often results in a large mass loss. You're driving off the water. Now flip the process. Suppose an unknown compound is 52.2% carbon, 13.0% hydrogen, and 34.8% oxygen by mass. How do we determine its empirical formula? First, assume a 100-gram sample of the compound. Next, convert each element's mass to moles and divide all the mole values by the smallest one. Finally, scale the resulting ratio to obtain whole numbers. Let's repeat the process on this example. First, we calculate the number of moles. Carbon gives about 4.35 moles. Hydrogen, about 12.9. Oxygen, about 2.18. Then, we divide all by 2.18 to get a 2 to 5.93 to 1 ratio. Rounding it up, the empirical formula is C2H6O. A few guardrails. Always include water of hydration when present. Always convert percentages to moles before comparing ratios. And delay rounding until the last step so tiny errors do not snowball. Here is a quick recipe for calculations. Identify the formula, calculate the total molar mass, take each element's share over the total molar mass times 100%, and then check that the percentages make sense. Let's recap. Percent composition is percent by mass, found by an element's mass share divided by the molar mass of a compound times 100%. You can use it to analyze simple molecules and hydrates. In reverse, percent data can lead to an empirical formula by converting to moles and comparing ratios. Now that you've watched the video, let's see how much you remember. Head to the link in the description where you'll find Quizlet content made just for you.